Hello everyone, I'm going to go over the ForecastBuilder version 10 NBM Precipitation Type methodology. This slide set is only for the NBM Precip Type methodology. All the other Precip Type methodologies, the top-down, the Bergewijn method, snow level prob ice, are all going to remain the same in version 10. Okay, let's discuss the NBM Precipitation Type approach real quickly. The NBM uses a modified Bergewijn top-down approach that accounts for ice nuclei, warm noses, and surface cold layers in wet bulb. The probability it produces are conditional, meaning that if precipitation occurs, it would have that probability of being that type. These probabilities are calculated by determining the precipitation type for each member and then seeing what the overall probability is of that precipitation type. In other words, what we're doing is not averaging up all the members and creating an average thermal profile. Here are the weightings in the NBM of all the members that go into creating these probabilities. The thing to know here is that within 60 hours there are a lot of members, and many of those are CAM or high resolution models. After about 84 hours though, the membership is small and only a few deterministic global models are used. And although the ensembles are used, just the ensemble mean is what is input into the equations. So here are the benefits to the NBM Precip type process and some concerns. So the big benefits are that it's meteorologically and statistically sound process. It also handles bimodal scenarios where existing techniques might give you a fictitious non-meteorological solution. The other big benefit is that the NBM is able to incorporate a lot more data sources than what we have in AWIPS. The concerns are that even with more membership than AWIPS, it's still very small, and there's a lot of work being done on that for version 4.1 of the NBM. So one of the major concerns to the NBM is that the bias correction causes a lot of spurious freezing rain forecasts. Freezing rain in the NBM can be forecast because a lot of times you have drier and colder solutions mixing with warmer and wetter, and the end result is some low probability of freezing rain, which isn't actually forecast by any model. So because of the model vertical and horizontal resolution, the precipitation output can struggle in the sharper terrain of the western U.S. So let's talk about how ForecastBuilder will use the NBM Precip types. The good news is that this has been totally reworked for this version of ForecastBuilder with a different philosophy and some better tools. So if you used the NBM method in the past and you had trouble with it, that's probably not a surprise. In the Analyze Adjust step, the NBM conditional probabilities are displayed in the pot rain, pot freezing rain, pot sleet, and pot snow grids. Remember, these probabilities don't mean anything until precipitation is actually forecast to occur. Editing of these grids in the Analyze Adjust step is usually not needed unless you're at a snow level site or are making major changes to the location or timing of precipitation in the short-term part of the forecast. Also, unlike the NBM method from last year in ForecastBuilder, you can pretty much ignore precipitation types you're not going to forecast. So for example, if the NBM is forecasting a 30% chance of pot freezing rain and you know that you're not going to mention freezing rain in the forecast, you can just ignore it here. If you do make edits to the probabilities in this step, you also don't have to ensure that they add up to 100% anymore. The only thing that you really do need to ensure is that the probability of the precipitation types that you do want to mention in the forecast are greater than 15% in time and space of where you want to forecast them. The NBM Precipitation Type method will involve a new step in ForecastBuilder. While a new step might sound like more work, remember we're replacing the thermodynamic and prob ice grids that the other steps used with this step. And the precipitation type accumulation step with this method is essentially a streamlined automated step now. The big advantage now though is you can easily make changes to the forecast unlike you've ever done before. This step will allow you to add, restrict, or remove any precipitation type. What you need to know here is that this step is an unconditional probability step, meaning what you see here in the precipitation type grids in this step is the actual value that you're going to get in the weather grid. A 20% value in the pot rain grid here will get you a slight chance of rain in the forecast. It's a set of grids that are a scalar version of the weather grid. Basically, if you want a slight chance of snow, you can just add it to the forecast here by drawing in a 20% value on the pot snow grid. In some ways, this is an old school method, but we've got some new tools to help guide the process along. The GUI at the right contains all the tools that you can use, and there's a lot of options that we'll go over in a bit. But if you're doing a warm season forecast with temps above 45 degrees, note that all the winter buttons will be hidden anyway. This step will give you the power to easily remove the NBM freezing rain false alarm forecast and give you control in situations where multiple unnecessary precipitation types are forecast in the extended due to inherent forecast uncertainty. So rather than having to mention low chances of rain, snow, sleet, and freezing rain, the forecaster here can determine the primary type or types of precipitation that they want to be in the forecast. These next few slides will go over the unconditional precipitation pot forecast. This step will run after the finalized step. A series of 6 pot grids will show up in the grid manager. These are pot R for rain chances, pot S for snow chances, pot IP for sleet, pot ZR for freezing rain, and pot drizzle and pot freezing drizzle, which we'll talk a little bit more at the end here. Remember that these are unconditional grids, so what you see in these grids is what you're going to get in the weather grid. So for instance, values of 55 to 74% will get you likely wording of whatever precipitation type that is. If you haven't already noticed, the names of these pot grids mimic the weather grid's naming convention, with R for rain, S for snow, IP for sleet, and ZR for freezing rain. Pot thunder and pot severe are also loaded now in this step to allow you to work side by side with the other weather types. If you'd rather do this in the non-precipitation pot step, like it used to be in ForecastBuilder, you can still do that, or you can ignore them here or there. It really doesn't matter. It's up to you. The one thing that you always want to do in the unconditional precip pot step is hit the Init All Pots button, which will delete the old grids and create new unconditional pots based on your pop values and the NBM pot forecast from the Analyze Adjust step. These unconditional pot values will be created anywhere the conditional pot grid is greater than 15%, or your pot limiter value. More on that in a little bit. It will also only create a pot value when the wet bulb temperature is appropriate for that type. In other words, even if the conditional chance of snow is 100%, it's not going to create a snow forecast where your temperature is 55 degrees. In warm season operations, this step will always be quick and easy, literally just hitting one button. When the NBM is performing well in winter situations, or you did some optional editing to the conditional NBM pot grids in the previous step, this will also be very easy. How about when you need to make changes? Like for instance, removing sleet and freezing rain from the forecast because the NBM is trying to forecast low probabilities of them, but it's either wrong or you don't want to mention them. There are 2 possible strategies. One of them is to hit the Init All Pots button to get a first guess. Here I'll manually delete these in the grid manager where sleet and freezing rain showed up, keeping just rain and snow in the forecast, like so. Or there's another way to do this. The second strategy is to hit Delete All Pots to clear the slate, then just hit the Create Pot R and Create Pot S buttons. You'll only get these precip types initialized. Note that you can use the edit area and time range options at the bottom of the GUI here. Let's say you only want freezing rain for Monday, but not for Tuesday or Wednesday, or for just a certain part of your CWA. Drawing edit areas and time selections is a great way to limit the initialization of any of these precipitation types. Okay, so of course it's not always going to be that easy. Because you have the power to change the pots in an unconditional step, we need to make sure that the pops and pots match each other. In other words, you can't forecast a pop of 50% in the Analyze Adjust step and then forecast an unconditional pot of 20% or leave precipitation types out altogether. So we need to make sure that your pots match your pops. Running the consistency check will make sure that nothing conflicts in that regard. Likewise, we'll also need to make sure that your precipitation types match the temperature profile or snow level forecast, meaning that we need to make sure that you didn't manually add in freezing rain, say where the temperature was 40 degrees. When consistency checks find an error, it will highlight the offending grids in the grid manager red, and it will give you a status message on what to do to fix the issue at the bottom. Let's go over some common consistency errors and the buttons that will fix them. If you have a pop and pot consistency issue, there's 2 buttons that you can use to fix it. You can either keep the pot and fix your pops, which will force your pop grid to match your pot grids that you just created, either by clipping or raising the value of the pop grid. On the right, you can see it has clipped out the value of my pop grid where I had no weather type. Usually forecasters don't want to run this button because often we like the pop grid and these holes aren't meteorologically reasonable. The keep pop fix pot will force your pot grids to match the pop. Again, this is the most likely choice. Here's what will happen when we run that. It will create a temporary grid that's called Copy Me to Pot that contains all of the offending grid points where there is no pot value. In this case, these grid points were forecast by the NBM to be snow, but our temperature forecast was too warm. This is a very common problem. So we have to tell ForecastBuilder what precipitation type we want these grid points to be. If we want rain, we'll copy them to the pot R grid. If we want snow, we can copy them to the pot S grid. But remember that the reason that these grid points didn't get put here in the first place was because it was too warm. It will create a temperature inconsistency next, which we'll go over in the next example. But first, let's talk about the copy and editing tools. The middle column are buttons that you can easily use to copy one precipitation type to another. These buttons act like smart tools, meaning they only work on the selected grid and on the edit areas if you have one. In other words, the choices here at the bottom of the GUI don't matter. The Copy To buttons all copy one pot to another pot. Always use the Copy To buttons on the Copy Me to Pot grid if you want to make things easy on you. These buttons are also an easy way to get a mixed forecast, like copying pot R to pot S when you want to get a mix of rain and snow in the forecast. The Copy From Pot button is also an easy way to bring pot values into the pot grid of your choosing. So say you want a sliver of sleet in the transition zone between rain and snow. Create a pot IP grid for that time range, draw an edit area where you want to mention sleet, run the Copy From Pot button, and sleet is now in the forecast there. So back to the other type of inconsistency. If the temperature forecast doesn't match your pot forecast, so let's say you have snow forecast at a wet bulb temperature that's too warm, or rain at 30 degrees. This inconsistency will be fixed either by keeping your pot grid the same and forcing your temperature or dew point or snow level, if you're a snow level office, to match the pot grid. The other option here is to force your pot grid to match the temperature elements you've already forecast in an earlier step. This will remove grid points where it's too warm or too cold for that precipitation type to exist. Let's see an example of this in action. In this forecast, I want to forecast snow, but temperatures are marginal and too warm in some locations, resulting in all this speckling here. I can force snow into the edit area of my choosing here, and run the Copy From Pot button. By running the Keep Pot Fix T option, I'm telling ForecastBuilder to find all of these grid points where a violation is occurring, and to lower the wet bulb temperature until snow is now legal. Okay, at this point, you're probably nervous that ForecastBuilder is going to change your foundation grids. Well, don't worry too much here. You'll have the option to go back and revert these changes back to the last saved copy. You'll get this under the Edit menu at Revert Forecast. The status message will tell you to look over them, because here's the reality. The brute force changes to the foundation grids are only meant for minor changes to clean up random grid points or to nudge the forecast in one direction or another. If you're making major changes, they're going to stick out, and it's a sign that you really should be changing your foundation grids because they're not in agreement with the precipitation forecast that you're trying to make. Let's go over the length of the pot grids. You don't really need to know this, but let's just go over it so that there's no mystery. Generally, the length of the pot grid is controlled by your pop grid. If the values are the same, they will be combined. Like here, the pop grids are 1 hour long, and so are the pot grids. When they're the same value, you'll see that this will be combined into one single grid. Things get a little bit more interesting when precipitation types are changing. In the old ForecastBuilder setup, you'd get hourly weather resolution out to 7 days because temperatures are hourly. As you know, we probably don't have the skill to provide that kind of forecast resolution in the extended periods. Thus, the pot grids will be initialized to be no less than 3 hours in the medium term of the forecast and 6 hours at the end of the forecast period. Here's an example of where the temperature is getting below freezing and a switch from rain to freezing rain is occurring. Rather than having 3 separate grids showing the freezing line progressing across the area, just one 3-hour grid where the weather grid will say both rain and freezing rain chances. Here on day 4 is an example where that resolution is 6 hours and both the rain and freezing rain will be mentioned, even if your temperature is below freezing only for 1 hour, say at 11Z. The advantage to all of this is that you have less pot grids to deal with, and that the weather grids are going to be cleaner for use in graphics and whatnot. If you want the extra detail in showing the timing of transitioning precipitations out in the extended periods, there's nothing stopping you from splitting these grids up however you want. Either do it manually or split up your pot grids and rerun the initialization. This setting can be changed in your office's configuration as well. So there are some other major advantages to having this unconditional pot step method at your disposal, especially for areas where there is terrain. I call this the advanced topic because once you're familiar with the method, you can do some really powerful things with just a couple clicks of the mouse. Purposely creating precipitation type conflicts is an easy way to add precipitation chances where your foundation grids allow it to be meteorologically possible. For example, let's say you want to add a slight chance of snow only to some mountaintops in the northern part of your CWA. This is accomplished by just drawing an edit area to circle the general area of the mountain range, assign a value to pot snow that you want your pop to be, run the Keep T Fix Pot button to cut out the snow where it's too warm, in other words, where the valleys are, run the Keep Pot Fix Pop button to assign your pot value to the pop. Another unrelated thing you can do is use the pot limiter grid to modulate weather mentions. You can lower this down to 10% to get weather with a mention of 10 or 11%, common with storms and drier climates. Likewise, you can restrict the mention of low probability pots in the initialization process. Say you don't want freezing rain mentioned unless the conditional probability is greater than 30%, then your pot limiter is the way to modulate that. So let's talk about another advanced situation, a really messy winter weather event, and how the initializations work in the probabilistic era. In a complex or messy winter weather event, if one precipitation type has more than double the probability of the next type, we'll do some special things. So for example, let's say that snow had a 70% probability and rain was only a 26% probability. Then the lesser type or types will be demoted to slight chance probability, or a flat value of 15%. This flat value of 15% is your signal that another precipitation type is dominant in the probability spectrum. Let's see how this manifests in a situation where a core of an upper level low is moving across and causing a transition from rain to freezing rain to snow. So everywhere you see where there's large areas of 15%, you know that another precipitation type is the most likely one. This can be your cue to remove these values to show a proper precipitation type transition. This kind of probability smearing is common when models disagree on the speed of an upper level feature. Without the demotion of precipitation types, it would be really difficult to see outlier probabilities in the GFE across time and space. One complaint about ForecastBuilder in the past has been the inability to forecast drizzle without a pop. Well, now with unconditional probabilities, you can create a grid with the drizzle forecast coverage you want. You can still use the pot drizzle instead of pot R in case you want the character of the liquid rain to be drizzle instead of rain. When using the NBM pot method, the conditional pot grids will return to the grid manager for viewing during the accumulation step. Behind the scenes, when accumulation values are calculated, a normalization or recalibration of your conditional pot grids will occur for only the precipitation types that you mentioned in the unconditional step. For instance, a forecast with a conditional probability of 33% chance of rain, snow, and freezing rain, where you ignored the freezing rain because it was a false alarm signal, will now normalize to just rain and snow in order to split up the QPF between them. 33% divided by 66%, or 1/2 of the QPF will be distributed to the snow amount. So let's go over things when you have multiple precipitation type methods in ForecastBuilder. In order to ensure you didn't accidentally select the wrong p-type accumulation method when you're using another p-type method like top-down, the same unconditional precipitation step consistency check will run if you try to use the use unconditional pot grids or the NBM probability of weather type method. If it sees an inconsistency, it'll ask you if you want to continue anyway. This is so that you don't do top-down p-type method and end up using old unconditional grids to create the accumulation grids. The same check will occur at the weather grid creation step, and if you have an error, you'll see a pop-up box like this. Getting a pop-up box doesn't necessarily mean you have to fix the error, but it's a signal that you may be using the wrong method in your weather grid creation. For offices where the NBM is not your default p-type method in the configuration file set by your IT, the unconditional step will default to skip. You can change this by right-clicking on it and selecting the workflow to stop at this step, or you can just left-click on it to go straight to that step. For offices in a warm climate or during the warm season, it's highly recommended that you set your default and your only precip type method to NBM, as it reduces other options and pop-up boxes and simplifies the workflow. This concludes the information for all the sites except for snow level size. Feel free to stop watching if you're a flatlander. The best way to get used to this methodology is to start in the warm season, and you'll get the hang of it as it starts to get colder. So going back to the Analyze Adjust step, for snow level offices, there's a few extra tools that you'll have in the GUI that will help you resolve conflicts between temperature grids, snow level forecasts, and P-type. I would say that it's important to run these tools and checks to get the best result out of your unconditional weather type step. Plus, it's a way to ensure that you're not forecasting snow level below the surface with a temperature of 45 degrees. This can lead to some public confusion anyway. The Check T and Snow Level Consistency button will show you where the possible conflicts are. I say possible conflicts because only one set is a mandatory fix, while the other may be one that you want to fix if you're not forecasting freezing rain. White grids are the grids that should be fixed, as you have snow level below the ground with a wet bulb temp that's too warm for snow. Just like the other consistency fixes, you'll either pick to keep your snow level and force your temperature, or vice versa. The pink grids are when the snow level is above the ground, but the temperature at the surface is below freezing. This means you may be suggesting freezing rain is in the forecast. Again, this fix is optional because most of the time you probably don't want freezing rain, but you might be in that type of situation where you do. Again, you'll fix this either by adjusting temperature up or the snow level down. So to summarize the option, change temps to match snow level will force temps up or down to wet bulb 2.5 degrees C to match your snow level. Change snow level to match temps will force snow level up or down to match those temperatures. Either button sets the snow level to surface elevation where wet bulb is 2.5 degrees Celsius or less, or uses a 6-degree lapse rate of forecast T to raise the snow level. Finally, there's a button called Pouts from Snow Level. This can dramatically improve your conditional pot grids and all the nooks and crannies of your mountain areas by using your snow level forecast to shift the probabilities of rain, snow, and sleet to match it. I'd recommend running this every time in the Analyze Adjust step, just to make the unconditional precipitation pot step as easy as possible. One note, there will be an 800-foot buffer zone between the listed snow level where both snow and rain can coexist. So that concludes this video. Thanks for watching.